This is lesson 922, problem 956, and I'm going to go over C, E, and F. All right, so letter C is 2/3 P minus 2 is greater than -4. Okay, so we need to solve the inequality and then graph the solution on a number line. So we solve these like regular equations. We're trying to get the variable alone. So I'm going to start by adding 2 to both sides. And so that leaves me with 2/3 P is greater than -2. All right, then I need to undo this fraction. So I'm going to multiply both sides by 3. So the 3 divided by 3 makes a giant 1, and I'm left with 2P is greater than -6. Then to get the variable alone, divide by the number in front of the variable, so divide both sides by 2. So now I have that 1P is greater than -3. And then I just need to graph that on my number line. All right, so my boundary point's at -3. It's an open circle because there's no equal to sign under the inequality. And this inequality says that P is any number greater than -3. So numbers greater than -3 are to the right on my number line. So I have my solution, and then I've graphed that on the number line there. All right, let's go ahead and look at letter E. This problem is 9K minus 4 plus 1 is less than or equal to 2K minus 3 plus 7K. All right, and we're going to solve this like we would an equation. So the first thing we want to do is combine like terms on either side of the inequality. So on the left, I get 9K, and then I want to combine the -4 and 1, which gives me -3, less than or equal to, and I'm going to add up my K's. 2K and 7K gives me 9K's, and minus 3 ones. And we want to keep solving for K, so I would maybe add 3 to both sides. And I have 9K is less than or equal to 9K. And then to get K alone, I will divide both sides by 9, which leaves me with 1K is less than or equal to 1K. So we need to figure out now what values of K can we, or what values can we substitute in for K to get the left side less than or equal to the right side. So let's just pick a number. How about 3? So if I replace the K's with 3, I get 3 is less than or equal to 3. And so we have to decide if that's a true statement. 3 is not less than 3, but it is equal to 3. So this is true. 3 is less than or equal to 3. It's true because they're equal. I'm going to pick another number. Let's say -7. So if I replace my K's with -7, I get -7 is less than or equal to -7. Well, that's also true because they are equal, and this is less than or equal. So you should see that this is true for any number you plug in for K. The left side is always going to be equal to the right side. So the statement that K is less than or equal to K is always going to be true for any number. So our solution is all real numbers. And then we'll look at what that looks like on a number line. Okay, so this is my number line, and I need to show that K can be any number because the answer is all real numbers. Then I'm going to just draw a line all the way through my number line with arrows going both directions, showing that K can be any number. Okay. Now let's take a look at F. F, we have 3y plus 1 is less than 3y plus 1. Okay, so I'm going to solve for y. So I'm going to start by subtracting 1 from both sides. And I have 3y is less than 3y. I keep solving to get y alone, so I'm going to divide both sides by 3. And that gives me y is less than y. So now I'm going to pick some numbers and substitute them in for y and see if we get a true statement. So maybe I pick the number 2. So let's see, 2 is less than 2. That is not true because 2 is equal to 2, so that didn't work. Maybe I try a different number, maybe negative 8. Negative 8 is less than negative 8. Again, not true because they're equal. So if there's no number that we can substitute in for y to get the left side of this inequality to be less than the right side. So there's no possible number, so our answer is going to be no solution. And on a number line, if this is my number line, I would just leave my number line blank. All right, so here's my solution. I got no solution, and then I would just leave it as a blank number line.